Yo guys, hello everyone. Welcome to the new YouTube channel. Let's crack chemistry. Here is me Aksharchak continuing with the class 12 organic chemistry syllabus episode 2 of haloalkanes haloarenes. If you have missed the episode 1 which I did yesterday, I will give you the link of the video in the description box. Make sure you go and watch it and please subscribe, like and share the channel. And make sure you stay till the end of this video to get the maximum benefit. Let's start. Next, yesterday we had spoken about classification based on number of halogen atoms attached. We spoke about primary, secondary, tertiary haloalkane. We saw the allylic compounds. Today we'll continue with a monohaloalkane. What is a monohaloalkane? If to the alkane, if you attach only one halogen, X stands for halogen, okay? One halogen atom, it is called as a monohaloalkane. If you attach two halogen atoms, let's say one chlorine, one bromine, या one iodine, one fluorine, अगर आप दो attach करते हो तो we get a dihaloalkane. What if you attach three halogen atom? We get a trihaloalkane. So very simple, not something difficult. Next, benzylic halides. This comes where the base compound is a benzene ring, which is C6H6. You all know benzene is an aromatic compound, it has resonance effect. So these are the compounds where the halogen atom connects to a sp3. Remember, this is very important. sp3 carbon atom, and that sp3 carbon atom connects to the benzene ring. Here is a short example you can see I have drawn. This is the halogen atom, as all of you can see. अब ये एक carbon atom है. This carbon will connect to the benzene ring. So the connection of this halogen atom to the benzene ring is via this sp3 hybridized carbon atom. Such compounds are called as benzylic halides. What are vinylic halides? The compounds where the halogen atom connects to a cyclic compound containing double bonds. Okay, that is called as vinylic halides. Note here, the cyclic compound is not a benzene ring. Okay, it can be some cyclohexene, cyclobutene, cyclopentene, where the pentene ring or the cyclohexene ring attaches to the halogen, any halogen, fluorine, chlorine, bromine or iodine. But the cyclic compound is not a benzene ring, it is any other cyclic compound containing double bond like cyclohexene, cyclopentene, etc. तो उसको हम कहते हैं vinylic halides. Next, what are aryl halides? Compounds in which the halogen atom will directly jump and connect to the benzene ring. There is no need of sp3 carbon atom or any other sp2 carbon atom in between. But halogen will come, it will directly go and attach to the benzene ring. It is called as aryl halides. You can see here, chlorobenzene we say, iodobenzene. So in all these what is happening? There is the benzene ring like this. Okay, resonance, and then let's say we have chlorine. So directly this attachment you all can see. So it is called as chlorobenzene. If iodine is there, iodobenzene. Bromine hai to bromobenzene. Fluorine hai to fluorobenzene. Next, nature of the carbon halogen bond. This is the carbon, this is the halogen. Whatever bond is formed between it is called as the carbon halogen bond. Now you all know कि carbon is more electronegative as compared to halogen is more electronegative as compared to carbon. So what will happen? Whatever are the electrons shared between carbon and halogen, they will move towards halogen. Why? Because halogen की जो electronegativity है वो ज़्यादा है carbon से. So as a result, the electron pair is shifted towards the halogen atom, and hence the bond is a polar bond. Okay, these compounds are normally colorless compounds. They don't possess any colors, your haloalkanes. So that's what I've written here. In this carbon halogen bond, the halogen atom is more electronegative as compared to the carbon atom. Thus, the shared pair of electrons are shifted towards the halogen atom. Thus, the bond is a polar bond, due to which your bond length will increase, cause greater the electronegativity, lesser is the bond length, and more stronger is the bond enthalpy. You guys have studied in your class 11 chemical bonding and molecular structures chapter. So that concept is being told here. So greater is the electronegativity of the halogen atom, shorter will be the bond length and stronger will be the bond enthalpy. Now if you go down the group, you can see, if you go down, suppose we have fluorine, we have chlorine, we have bromine, we have iodine. Okay, so as you go down the group, the electronegativity will increase. The electronegativity will decrease. So what we can see that fluorine is the most electronegative and iodine is the least electronegative. So when you attach fluorine to carbon and you form a fluorine carbon bond, the energy required to break the bond is very high. On the contrary, if I attach iodine to this carbon, okay, and if I try to break the bond, the enthalpy is not so much, because as you go down the group, electronegativity decreases, the metallic character increases. So the CF bond is more shorter, it needs high bond enthalpy, whereas the iodine, the carbon iodine bond is less shorter. It is less shorter means it is a bit longer than the CF bond, and the bond enthalpy is not so much. Less energy if you use, you can break the bond. That is the concept here. And guys, before moving further, if you like this video, please share it and subscribe. It may be helpful to millions of students who are watching this. Okay, this is my new YouTube channel for chemistry. Next, methods of preparation, and make sure you are watching this video till the end to get the maximum benefit. Okay, methods of preparation of alkyl halides. Now we talked about the properties, what is a haloalkane, what does it look, but how it is prepared, that we need to know. The first one is alcohol. Okay, the chemical formula for alcohol is ROH, ethyl alcohol, propyl alcohol. We have been studying about alcohol from class 10, carbon and its compounds chapter. Now we take alcohol, we add it to HCl acid, very strong acid. This is very corrosive in nature, we have to use it safely. We get RCl plus water. Here the reagent used is zinc chloride. Okay, so these two reactants, when you add zinc chloride, this will form alkyl chloride. If you take ethyl alcohol, ethyl chloride. If you take propyl alcohol, propyl chloride, corresponding chloride you will get. Clear? Next, we take alcohol, we add NaBr under H2SO4. This alcohol will react with NaBr under the presence of H2SO4 to give you RBr, alkyl bromide, and this NaBr and H2SO4 will again react together to give you NaHSO4. Now, like the previous reaction, water is the minor product, the side product. So even if you don't mention it, there won't be any problem. Next reaction, we take alcohol, we add PX3, phosphorus trihalide. We get the corresponding haloalkane with S3PO3. Okay, so if I take ethyl alcohol, I'll get ethyl chloride. Suppose if I take ethyl alcohol, I may get ethyl bromide. So here the X is chlorine or bromine. If you are using phosphorus trichloride, you will get ethyl chloride. If I am using phosphorus tribromide, I will get ethyl bromide. Now, why have I only written here chlorine or bromine? Why not iodine or fluorine? Why? Because fluorine is the highest electronegative. It is very easily gaining 1 electron to get the octet stability, the noble gas configuration which you guys say. So this fluorine is so reactive that if it forms a compound, it will catch fire. It will catch fire, very highly reactive. So we can't use fluorine, it's very dangerous to use. Okay, not so safe. Iodine. Iodine is a very slow reaction. Okay, you do it for a long time, but it is very slow. You may have to use strong oxidizing agents. So one is very fast reactive, one is very slow reactive. That's why we only use chlorine or bromine. They are medium, they are suitable to use. Next, ROH plus PCl5, phosphorus pentachloride. Okay, if you take ethyl alcohol, you will get ethyl chloride. If you take, let's say, butyl alcohol, you will get butyl chloride, etc. And you are getting POCl3, okay, and you are getting HCl. Okay, so the first reaction was ROH plus HCl giving you RCl plus water. Here we are using zinc chloride as the reagent. Second reaction was ROH plus NaBr plus H2SO4 will give you RBr and NaHSO4. Here R can be either chloride or bromide. Next, ROH plus PX3 giving you RX plus S3PO3. Again, X, it can be alkyl chloride, alkyl bromide. It is not advisable to use chlorine or iodine. I told you the reason before. The last one, ROH plus PCl5, again alkyl chloride. Okay, we will get only chloride here, not bromide, because ये PCl5 है, so there is no question of getting a bromine. तो PCl5 हमें automatically क्या देगा? RCl. If you are using ethyl, ethyl chloride, propyl, propyl chloride, and POCl3 plus HCl. This was it for today. If you like this video, please like, share and subscribe, and do watch the video till the end after it's uploaded, okay, to get the maximum benefit. Please like, share and subscribe. See you soon guys. Bye.